Hello and welcome to NAB 2023. We are here at the ARRI booth. My name is Stefan and I'll give you a short introduction into color management with virtual production. In virtual production, you basically are using an LED wall to display a background for your camera. This background can be a 2D plate or a full-blown 3D scene, which is only existing in the virtual world. But the point for color is that it is displayed on an RGB wall. And this RGB wall is made to please the eye. But, you know, that's a camera, and the camera has totally different sensitivities on its sensor, so what you do for the eye won't match for the camera. There are basically two major things that you need to take into regard. One is all displays are fit out with a brightness encoding function that is a gamma curve or a PQ curve for HDR displays, and the camera is not. It expects a linear coding of your brightness. And the second thing is the camera is expecting natural colors that are lit with high CRI spectra, but the LED wall as a display is having three very peaky RGB spectra, and that's why the colors shift and they look wrong in the camera if you have a virtual scene in the background or virtual content in the background and a real scene in the background. That's what you need to manage. This is pretty stable actually. Of course, the LED walls react to heat. If they get warmer, LEDs tend to decline their brightness output, but that is in one particular scene when the brightness is kept at a certain level, also the temperature is staying stable and also the colors are staying stable. There is a angle sensitivity to the colors, so if you get too far away from an optimal viewing angle, the colors tend to shift away. But that's something you can manage rather easily if you do a measurement up front and then simply increase or decrease certain color channels depending on the camera position. At first, you can measure the LED wall and the camera. It cannot be seen as two separate devices, but it is one device generating the image with, of course, real set in between. But in the end, it's one display device that is providing an image. Second, you need to calibrate this device with a certain color matrix, which is actually repeating the color management in the camera, but in an inverse way to put it on a proper display. And second is, you need to hand out this as an application so that users can actually use it and maybe apply whatever the DOP is used to. Change CCT, change stops, or whatever you want to do as a cameraman. You display certain colors on the LED wall, mostly R, G, and B, like the LED wall channels, what they can maximally produce, and a grayscale on the LED wall, so that you know how it behaves over the complete range. You measure that with your sensor, that's important, and then do some mathematics and calculate the inverse matrix out of that. Or with the reveal color science, it needs to be a bit more complicated, but in the end, the principle is the same. When you have your measurements, when you have your calibration matrix, you somehow need to apply the calibration matrix in your closed system where it will help you in a way. If you would apply the matrix in the camera, that wouldn't be a good solution, because then you would have the same calibration on your real props up front. So all your actors and your stuff would be in the wrong color. If you would apply it in the LED wall, you would lose some information, because this signal is already coded in a certain way that the values are only between 0 and 1, and you would lose all the brightness clipping, for example. The only way to apply it properly would be in your footage playout system, which can be for 2D systems like Disguise, Pixera, Viva-V or other systems, or for 3D content it can be Unreal or Unity. And you need to apply it in a so-called linear color space that can be ACES, ZG or sRGB, but it needs to be linear because only there you don't have any information loss when you apply a inverse calibration matrix and only then you go out of that linear color space into a, well, transmission route to your playout system, whatever it is. Well, let's stick to Unreal for the moment. First thing is, of course, we can do the measurement, we can do the application in Unreal, but what's more important, in only a few months, maybe anyone can do it. That depends on how we put out the product. It's still in discussion, but there is a possibility. You simply download the software, do the measurements, send us your data for the calibration, get a matrix back, and then you can apply this matrix in Unreal Engine via the LiveLink plugin that we provide. In Unreal Engine, we would deploy, or you can download already a LiveLink plugin from our homepage, which does not only apply the matrix that we have spoken before for the color correction, but also is providing you with some handles that are used from the camera, so that you can use the camera in your traditional way that you have learned over the years. You could apply a color temperature to the footage on the scene, and if you would apply the same color temperature on the camera, they would match perfectly. The same goes with tint or with brightness or other things that you need to do your shoot. When it comes to image quality, I would recommend all of them, because they all have a great sensor in it. They all come with the cinematic lenses where you have a very shallow depth of field, which is very much helping against moire. But where they divide it a bit is in connectivity. For example, with the large cameras, the Alexa or the Alexa LF, you cannot apply a gen lock. You need to synchronize the camera with timecode, which is also perfectly doable, but a bit more tedious than doing the gen lock. With the minis, the Amira and also the Mini LF, the synchronization issue is away. So you simply apply Genlock to it and it works perfectly. But you do not only want to have Genlock, you also want to have lens metadata, for example. And therefore I would heavily recommend the Super 35, because this camera is already delivering live metadata through their Ethernet connector, and you do not need an additional device to collect it. For the other cameras, there's also a workflow existing, but you would need a UMC4 to collect the metadata and send it without lag to Unreal Engine.